All right, this is Unit 6, Lesson 3, Logarithms. So our lesson essential question is, what are logarithms and how are they evaluated? At the end of this lesson, we'll be able to evaluate and simplify logarithms. Example 1, understanding logarithms. To solve the equations 2x equals 8 and 2 to the x equals 8. You can use inverse operations to solve the first equation. Division is the inverse of multiplication, so you can divide both sides by 2 to solve the equation. So 2x divided by 2 equals 8 divided by 2, so x equals 4. The operation in 2 to the x equals 8 is exponentation. To solve this equation, you need an inverse for exponentation that answers the question. To what exponent would you raise the base to get 8? The inverse of exponentation is called a logarithm. To solve the equation 2 to the x equals 8, you can write log sub 2 of 8 equals x. Log sub 2, 8 is read logarithm base 2 of 8 or log base 2 of 8. Solving this gives log base 2 of 8 equals 3 because 2 to the third power equals 8. The logarithm base b of x is defined as follows. Log base b x equals y if and only if b to the y equals x. For b is greater than 0, b cannot be 1, and x is greater than 0. The logarithmic function y equals log b x is the inverse of the exponential function y equals b to the x power. Write the logarithmic form of y equals 8 to the x. So x equals log base 8 y. So I take this, that becomes my base, x where my exponent is, and y. Concept, exponential and logarithmic forms. Exponential form shows that a base raised to an exponent equals the result. So a to the b power equals c. In logarithmic form shows that the log of the result with the given base equals the exponent. So log base a of c equals b. When written in logarithmic form, the number that was the result of the exponential equation is often called the argument. Example 2, convert between exponential and logarithmic forms. What is the logarithmic form of 3 to the 4th equals 81? Okay. The base is 3, the exponent is 4, and the result is 81. So in logarithmic form, 3 to the 4th equals 81 becomes log base 3 of 81 equals 4. The logarithmic form of 3 to the 4th equals 81 is log base 3, 81 equals 4. What is the exponential form of log base 10 of 1,000 equals 3? The base is 10, the exponent is 3, and the result or argument is 1,000. So in exponential form, log base 10 of 1,000 equals 3 becomes 10 to the third equals 1,000. The exponential form of log base 10 of 1,000 equals 3 is 10 to the third equals 1,000. All right, so let's try it. What is the logarithmic form of 7 to the third equals 343? So the base is 7, the exponent is 3, and the result is 343. So writing this in logarithmic form, I have log base 7 of 343 equals 3. Okay. For b, what is the exponential form of log base 4 of 16 equals 2? So my base is 4, my exponent is 2, and my result is 16. So in exponential form, I have 4 squared equals 16. All right, example 3, evaluate logarithms. What is the value of the logarithmic expression log base 5 of 125? So think 5 to the what power gives me 125. Since 5 cubed equals 125, log base 5 to the 125 equals 3. What is the value of the logarithmic expression log base 1/4 of 16? So think 1/4 to what gives me 16? Well, 1/4 to the -2 equals 16. So log of base 1/4 of 16 equals -2. What is the value of the logarithmic expression log base 3 of 0? So again, think 3 to the what gives me 0. There's no such power, so it's undefined. For log base 2 of 2 to the 8th power, think 2 to the what gives me 2 to the 8th? Well, that's 8. So 2 to the 8 equals 8. So let's try it. What is the value of each logarithmic expression? Log base 3 of 1 over 81. So think 3 to the what power equals 1 over 81. Well, in this case, x is going to equal -4. So 3 to the -4th gives me 1 over 81. For B, log base 7 of -7. So 7 to the what power is going to give me -7. This is undefined because nothing's going to give me -7. For C, I have log base 5 of 5/9. So 5 to the what power will equal 5 to the 9th power. Well, in this case, x will equal 9. Or the question mark will equal 9. All right, concepts, common logarithms and natural logarithms. So the base 10 logarithm is called the common logarithm. That's the one we use the most often and is written as log x. The base of 10 is implied. The base e logarithm is called the natural logarithm and is written as ln x. The expression log base 10 of x and log x mean the same thing, as do ln of base e x and ln x. Okay. Example 4, evaluate common and natural logarithms. What is the value of the logarithmic expression to the nearest 10,000ths? So I have log 900. So again, you want to remember that this is base 10. It's implied that it's base 10. So log of 900 is approximately 2.9542. I can check by writing the expression in exponential form and evaluating. So 10 to the 2.9542 is approximately 900. Okay. You can use calculators for these. What is the value of the logarithmic expression to the nearest 10,000ths? ln e. Remember, e is that base. So ln e equals 1. Check by writing the expression in exponential form and evaluating. So e to the first power does equal e. The value of ln to -1.87. Okay, so that's e to the what gives me -1.87. There actually is no exponent to which e can be raised in order to get a negative number, so ln to the -1.87 is actually undefined. So let's try it. What is the value of each logarithmic expression to the nearest 10,000ths? So log of 321 equals 2.5065. For B, ln of 1,215 gives me 7.1025. And for C, log of 0.17 gives me -0.7696. All right, example 5, solve equations with logarithms. What is the solution to the equation round to the nearest thousandths? So A is 25 equals 10 to the x minus 1. So 25 equals 10 to the x minus 1. So I have log of 25. Remember, log base 10 is our common logarithm. So log of 25 equals x minus 1. So 1 plus log of 25 equals x. So x equals 2.398 approximately. Okay. So basically what we did was we said, okay, well, it has a base of 10. So in order to get the x minus 1 by itself, I need to take the logarithm. So it's an exponential form. I need to change it to a log. So that's log of 25 equals the log of 10 to the x minus 1, which simplifies to the x minus 1. Okay. So what is the solution to the equation? Round to the nearest thousandth. I have ln 2x plus 3 equals 4. So remember, ln is base e. So I'm going to take 2x plus 3 equals e to the 4th. Which gives me, e to the 4th gives me approximately 54.598. And that's 2x plus 3. I subtract 3 from both sides and then divide by 2. So x is approximately 25.799. All right, so let's try it. I have log of 3x minus 2 equals 2. Okay, so this again is base 10. So log base 10. Base 10. The exponent is 2, and the result is 3x minus 2. So I can actually rewrite this as 10 squared equals 3x minus 2. Well, this gives me 100. 3x minus 2. I add 2 to both sides, or 102 equals 3x, and then divide by 3, which gives me x is, so x equals 34. For this one, b e to the x plus 2 equals 8. So this is going to be a base of e. So base is e. Exponent is x plus 2 equals, and then the result is 8. So I have ln sub e 8 equals x plus 2. Remember, you don't have to write that ln with the base of e. You can just write ln of 8 equals x plus 2. It's the exact same thing. Okay, I'm just writing it for clarification. I'm going to use my calculator to put that in. Okay, so hang on this calculator. This is my calculator right here, the TI-73. So I'm going to hit the math button, okay, which gives me this menu right here. And then I'm going to actually go over to where it says log at the very top. 1, 2, 3. Yep. Okay. So this gives me a couple options. This gives me log. It gives me 10 to the what power, ln, and e to the what power. Again, these are going to be common, your common and your natural logs. They're not going to give you bases. They're not going to give you other base options. So I'm going to go ln, which is the third option, enter, and then I'm going to enter ln to ln 8, which is what I'm looking for. I hit the enter button and it gives me this, the 2.07. It gives me that answer. Okay, so that gives me that option. 2.079, which equals x plus 2. Okay, then I'm going to subtract 2 from both sides, so 0.79 equals x, and this is actually approximate because it's not exact. So 0.79, 0.079, sorry. Check the answer. All right, example 6, use logarithms to solve problems. So the seismic energy X in joules can be estimated based on the magnitude M of an earthquake by the formula X equals 10 to the 1.5 M plus 12. Joules, just so you know, is a unit of measure. Usually it's used in physics, sometimes in chemistry, but usually in physics. So it's just a measure of energy, just so you know. What is the magnitude of an earthquake with a seismic energy of 4.2 times 10 to the 20th joules? So earthquake magnitude scale, 2.5 or less, 2.5 to 5.4, 5.5 to 6, 6.1 to 6.9, 7.0 to 7.9, or 8.0 or greater. So this is dealing with earthquakes. So I formulate, substitute 4.2 times 10 to the 20th for X in the formula. So here's my X value. So 4.2 times 10 to the 20th equals 10 to the 1.5 M plus 12. Solve the equation for M. Okay, so 4.2 times 10 to the 20th equals 10 times 1.5 M plus 12. So I need to get this M by itself. So remember base 10, so I can take the log of the other side. So log of 4.2 times 10 to the 20th equals 1.5 M plus 12, which gives me, when I simplify this, again, using calculator, gives me 20.6 approximately equals 1.5 M plus 12. I subtract 12 from both sides and then divide my answer by 1.5 to get 5.75. So the magnitude of the earthquake is about 5.75, and I can always verify that by substituting that value back in for M to make sure that it actually does give me the 4.2 times 10 to the 20th, or right around that answer. All right, so let's try it. What is the magnitude of an earthquake with a seismic energy of 1.8 times 10 to the 23rd joules? Okay, so again, I'm going to use this same formula, this X equals 10 to the 1.5 M plus 12. And I'm going to substitute in for X. I'm going to substitute in the value that they gave me. So I'm going to have 1.8 times 10 to the 23rd equals 10 to the 1.5 M plus 12. Okay, so I take the log of this. So log of 1.8 times 10 to the 23rd. Equals the log of 10 times to the 1.5 M plus 12, which gives me 1.5 M plus 12. Okay, so my log, so I'm going to go into my calculator. I hit math. I go over to log, so I push the red button, then I went over 4, and then log, which is 1. Okay, so now I have that. Then I'm going to enter in exactly what I see in the problem. So in this case, it's 1.8 times 10 to the 23rd. Okay, so notice how I use parentheses. Okay, then I push enter, which gives me that. 23 and some change. So 23.25527, approximately 1.5 M plus 12. I subtract 12 from both sides, which gives me 11.25527. That's 1.5 M, and then I divide both sides by 1.5. So 7.504 is approximately M. So the magnitude is about 7.5. All right, concept summary, logarithms. So in exponential form, you have b to the x equals y, and in logarithmic form, you have log base b of y equals x. Okay. So in words, the base raised to the exponent is equal to the result. So an example is 3 to the 4th equals 81. In logarithmic form, the logarithm with a base b of the result or argument is equal to the exponent. So log base 3 of 81 equals 4. And that is the end of Unit 6, Lesson 3.